We've looked pretty extensively at sine and cosine functions and their graphs. Today we're going to look at tangent, cotangent, secant, and cosecant. The first thing that I'm going to let you know is that you are not expected to have the same detailed knowledge of these four as you are of sine and cosine. However, based on your knowledge of sine and cosine, you are expected to understand how the rest of these work. So the first thing that we talk about is the tangent function is odd. It has a period of pi and has asymptotes at odd intervals of pi over 2 or 90 degrees. So let's start with the word asymptote. An asymptote is an imaginary line on a graph. Your graph never actually touches this line, it only approaches the line. And you will see asymptotes on various different types of graphs for the year. So we are going to start by proving the fact that tangent is an odd function. You need to remember that tangent is equal to sine over cosine. That doesn't change. Now, sine, because of the way that the graph works, is an odd function. If you think about what that looks like, I'll draw a small sine graph here, right? It does this. That's an odd function. Cosine is an even function, if they were drawn better. Which means that if I put in a negative value for x in both of them, you get that the tangent of negative x is equal to the sine of negative x over the cosine of negative x. Simplifying that further, that would mean we have the negative sine of x over cosine of x. This gives us a negative tangent. So here what I'm seeing is I have tangent, negative tangent. This is the positive, this is the negative, so tangent must be odd. The next component that I'm going to address are the asymptotes. So if you remember, if we put in any angle here, the tangent of this angle, whatever we want to call it, is going to be the y value over the x value. Which really is another way to say rise over run. So we should have figured out by now that the tangent is the slope of this line. Well, as we move around the circle, this slope increases and increases until it becomes vertical. When it's vertical, that slope is undefined. That's also when we start looking at that point 0, 1, and we said the tangent was 1 over 0, which is undefined. That's part of why that happens. Then as we progress, we have negative slopes here until we have a slope of 0. Then our slopes become positive again, increasing until it's undefined once again. And then our slopes are negative once more until they hit 0. So these places here and here are where you're going to have asymptotes. When we look at the period being theta, what we're looking at is, and not theta, I mean pi, we're looking at these sections in between the asymptotes, because our slopes are negative, 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 0, positive, positive, positive. And then it starts again. Negative, 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 0. Positive, 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 undefined. So that's why we say that the period is pi, because between where it's undefined here and undefined here, our slopes have a pattern. So what does the graph of tangent look like? Well, this is what it looks like. If you think about going around that unit circle, you start here with a slope of 0. and your slopes increase, 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 increase until 90 degrees or pi over 2, and that's where you have an asymptote. And that's the asymptote. Now, when we come off of that vertical line, our slopes are negative, but they slowly become less negative until they're 0 right there at pi. Then they become more and more positive until they near 270 degrees or 3 pi over 2, and we have another asymptote. You can see right in here is the period of the graph. So from pi over 2 to 3 pi over 2, that pattern is what will continue to repeat itself. And here's your asymptote. So the next question asks, we'll determine whether or not secant is odd or even or neither. Well, we know something about secant. We should know that the secant is the same as 1 over the cosine. Well, if I put negative x in for them, so if we're looking at a specific angle that we're taking the cosine of, if we take the cosine of the negative value of that angle, we know because of all students take calculus, the cosine will be the same. So in this case, it still will be cosine of x, or 1 over cosine of x, which means that the secant, because after I put in a negative x is the same as my original, secant of x is even. This is what the graph of secant of x looks like. The first thing that I'd like you to pay attention to are the locations of these, what we call local max and minimum. We don't really have maximum and minimum values here because, truthfully, this graph continues infinitely in the positive and negative directions. But if you take a look at where these points intersect, what you will see is that you can connect them with a cosine graph. You should also notice that the asymptotes on this graph occur in those locations where cosine is 0. Because if secant is 1 over cosine, then anytime cosine is 0, we end up with 1 over 0, which is where we get an asymptote. In this example, we are asked to graph 2 times the secant of x. So to start, I am going to note this as being positive 2 and this as being negative 2. What I will do first is I will graph this as though it were cosine of x, because that's something that I'm pretty comfortable graphing. And in this case, it would be 2 times the cosine of x, because here we have got an amplitude of 2. The next thing that I'll do is locate my asymptotes in any place where cosine crosses the x-axis. And from there, I'll sketch in my graph. For this next one, we're asked to graph the tangent function. Now, tangent doesn't change amplitude because it continues infinitely in both the positive and negative y directions. However, we can change the period of the function, meaning that we can squish it together or spread it further apart. Now, when we were dealing with sine and cosine, in order to find the period, we needed to take 2 pi over b. That's because the regular period of sine and cosine functions is 2 pi. For a tangent function, the regular period is pi. So in order to find the period of our function, we need to use pi over b. What that means is that the period of my new function is pi over 2. So now I'm going to start at 0. But I'm not going to go straight to pi over 2 because remember, tangent before kind of got split in between these values. So what I need to do is I need to split halfway in between here. Because this negative pi over 4 plus pi over 4, these two distances being equal, only one in the negative direction, one in the positive, will add up to be pi over 2. If I'm going to continue, this would be 3 pi over 4. Here's 5 pi over 4. And that also continues negatively. So the asymptotes are going to be in these locations. And this graph will do kind of like this. I am not expecting your graphs to be perfect.